Hi, everyone. It's great to meet you all today. The topic that I will be choosing to cover is how to choose the right problems to solve with machine learning. So my name is Angela, and just before we get into all the stuff that we will be covering, I wanted to give a little bit of an introduction on myself. I am a product manager at Spotify in the freemium organization. I currently work on the commerce platform, which supports all things that are commerce related for the main Spotify product, which I'm sure you guys are all familiar with, as well as the creator and ad space within Spotify as well. My team in particular focuses on data products, which breaks down into an insights platform as well as various ML capabilities. I am from Canada, so my last job was actually at a telco called Bell. I worked as a PM in the BI space there and was also building up various analytics and ML capabilities. So data products have been a very big part of my career foundation, and it's an area that I've been incredibly interested in. The topic that I wanted to cover today is really interesting to me and comes a lot from my own experiences and what I've learned over the years. This is just information that I wanted to pass on to kind of demystify the space for PMs of any data and machine learning level experience, as well as to start up some conversation. If you have any thoughts or are a data and ML PM yourself, I'd love to end up hearing from you. So jumping into it. First of all, why does finding the right problem actually even matter for machine learning? The first piece might seem obvious, but we want to build machine learning to actually solve a business problem. I think the area of machine learning is generally seen to be very cool, and a lot of the times we can catch ourselves looking to build machine learning, but not actually solving a business problem. If we find a good business problem, this ensures that we have stakeholder buy-in. And this is super, super important because a lot of the times we aren't going to be building machine learning products on our own. A lot of the times we may need data from another team, or we may be integrating our machine learning product into the front end of another team's. We also want to make sure that we're investing our time and resources in the right area. This is also really important with ML development, since a lot of the times ML products do take a lot longer to develop since you are teaching a system to become the product. So it's really important that we're choosing the right problem spaces to be focusing on. There are also problems that should not be handled by machine learning. And to avoid the cost of error of choosing problems that shouldn't be handled, it's really important that we're evaluating what the cost of error is going to look like and whether or not there are even trends that can be learned by machine learning, or if this should be something that should just be handled by a rules-based approach. The last two pieces are just making sure that we have the right technical landscape to be building ML products. So we want to make sure that we have the right resources when it comes to skills, data, and technology to actually invest in the problem space, and that we're at the maturity level that's needed. And we also want to forward sight and take a look at what types of production and scaling blocks may come into play. I have a great example here where our team was looking at building a ML product to integrate into a website that would provide recommendations to our users. And what ended up happening was the website actually wasn't capable of handling dynamic inputs. And so us knowing that months before we even began looking at development was incredibly helpful, so that we avoided these production and scaling blocks and didn't look to invest in this area. So these are just a couple of reasons why finding the right ML problem actually matters. There's a lot more to it, but this is just a quick overview of why this topic is very, very important. So how do we actually go about finding the right ML problem? I like to think of this as kind of evaluating the landscape. Once we actually have a problem in play, I like to take a look at what the landscape is like on two important pillars. One is, what is the business impact, as well as what is the technical feasibility of actually bringing this ML problem to life. Oops. So if we look at the criteria that we should be considering on each of these two pillars, the first pillar to look at is the business impact. And so some of the criteria here that I usually like to consider is, what is the actual business problem that we are solving, and what is the impact that we would have on our KPIs? So a lot of the times at Spotify, when we are looking at what types of ML problems to invest in from a business perspective, we typically take a look at the number of users that would end up being impacted, as well as figuring out how this plays into our KPIs and whether or not this falls in the direction that we are trying to take as a team. there are some problems that impact, let's say, only 0.5 million and some that impact 3 million. So it's really important to consider what the potential impact could look like when evaluating multiple options. Another piece that we like to consider as well is whether or not we are building an ML application or insights. And so a lot of the times applications will, or if we're building an ML product for an application, there's a higher likelihood that it'll get reused over and over since it's part of a system and part of a process. Whereas if we're building an ML model for one-off insights, it may or may not end up getting used. So I personally like to veer on the option of choosing ML products that are going to be integrated as an application. This is also really important as well, as applications, typically you'll be end up working with another team. So you may need to consider who you need to get on board in order to make this happen. The last piece that might seem last piece, but definitely not the least, is to consider what the risk level is that we are ready to have for developing an ML product that can automate the solution. So some pieces to consider here is, do we have the right data to avoid bias? So building ethical ML products is, of course, very, very important. And also to consider how high is the cost of error. There are times where the cost of error is so high and may frequently end up happening that we may not want to use a machine learning problem to resolve these issues, or we may want to have a higher mix of a rules-based problem or a rules-based approach as well as an ML-based approach to be able to counteract that. The second pillar to consider is usually one that we look at after we consider the business impact and whether or not this is a problem that is even important for us to go after. The second pillar is the technical feasibility and kind of covers some of the technical landscape of where we are at today as a business. So the first piece, and one that is super, super important, is to consider the data availability. So I think I mentioned a little bit earlier, one is making sure that we have the right data to avoid bias, but also, do we even have the right training data to be able to build up an ML product? This is especially important when we are looking at supervised problems, and this is typically pretty common if you're doing any sort of churn prediction, if you're looking at doing recommender systems as well. A lot of the times it's very important for us to have the right training data. Getting labeled data sounds a lot easier than it is, and then it's actually available. So it's always very important for us to have the right amounts of labeled data in order to be able to train up a model. From my own personal experience, this can oftentimes be a very big blocker and can prevent us from going after certain problems if we don't have the right label data to train up a model. The second piece that we often consider as well is ML solvability. So can this be a problem that will actually be solved by machine learning, and what exists in the solutions today? And so typically we try to avoid problems that use extremely cutting edge technology within machine learning that hasn't been tried and tested before. A lot of the times, if you're using something that has been tried and tested, it can be a lot easier. And there are also some problems as well that just cannot be solved by machine learning. So the second piece that we consider is ML solvability. And so what we consider when we're looking at machine learning solvability is whether or not a problem can actually be addressed by machine learning. Some things that we consider here are, there are some problems where there are so many edge cases and not enough trends that can be picked up that this isn't a problem that's good to be solved with machine learning, or that machine learning doesn't actually provide too much of a bump compared to our heuristic rules. Also, there may not be tech available today that is possible for us to use to address this machine learning problem. So this is something that's important to consider when we're looking at how solvable this problem is by machine learning, and not all problems, to our surprise, are actually able to do that. The last piece that we consider is system maturity. So can we actually put this machine learning model into production? I think I gave the example earlier where we found out pretty early on that the system that we were planning to integrate our model into wasn't actually able to handle dynamic inputs. So this is a great example of being able to evaluate system maturity and make sure that the system that you're looking to integrate into can handle the outputs of your ML product. Another piece to consider as well is, do we have the computational power to actually scale the machine learning model to be able to provide calculations for individual users at scale? And also, are we able to actually get feedback for this ML problem? This is a big piece that people oftentimes tend to forget. But the important part about machine learning problems is that we can get feedback and that we're able to use this to retrain the model. A lot of times, I found that developing a machine learning model, getting to the development of the model may not be that difficult, but figuring out how to put it in production can often be 80% of the work. And it usually requires some complex or technical design. So one thing that I also wanted to recommend and take a look at was this idea of an ML scorecard. We typically have used this quite a bit as a team, and within the rest of the business unit as well. We've used this way to measure and to basically evaluate multiple options at a single time. Oftentimes, there may be many stakeholders that are coming to you with different problems that they want you to consider from an ML perspective, or your team may have gone out and taken a look as you were doing product discovery and found that there were multiple problem spaces that you wanted to consider. So when it comes down to times like this, I find using an ML scorecard or using a weighted decision matrix, as you can see here, can often be very, very helpful. And the way that we go about doing this is we add in the criteria that was mentioned on the previous slide. And I definitely encourage each and every one of you to consider individual or criteria pieces that are important to you and the business as well, because it will vary depending on what business you're in. But here we usually take a look both at business impact and technical feasibility and decide on the weighting. I did want to mention that across the business impact pillars and technical feasibility, this isn't something that I as a PM usually do all on my own. A lot of the times when we get down to technical feasibility, I rely a lot on the engineering manager in my team, as well as the ML engineers to help evaluate the landscape that we are in. We usually also assign weightings for each of the criteria. Some things are a lot more important to us than others. Data availability is a huge one for us that we usually assign a lot more weighting to. So that's something to consider as well. And then following that, you can evaluate and put together basically a weighted score and a sum product that you can look at to compare the final scores of all options. One note on this method as well is not to think of this as an exact science. I've definitely run into these scenarios on my own where I've considered this to be, we get very in the weeds of taking a look at what is the exact number that we want to go after, but think of it more as a relative comparison to prioritize options rather than trying to get it down to an exact science or number. So an example of this is if we consider the criteria of data availability and we're looking at option 1 versus option 2, let's say option 1 has much more of the data available that we would actually need, we would weigh that higher than option 2. So consider it more a relative exercise versus getting it down to an exact science. I wanted to share some examples and kind of bring to light all the criteria pieces that we had just talked about and provide some examples of what is good versus bad. So if we want to take the first example, this is one that my team actually came across. So let's say a team wants to automate the classification of customer support tweets as needing advisor support or not. This was a problem that we looked at, and the landscape that we were looking at it in was that the automation that we were looking to build could save substantial cost for the customer support business. There was a lot of labeled training data available because if an advisor responded to a problem, then it was very easy for us to take that as a yes or no for whether or not they needed the support. And there was already a heuristic systems in place that was very complex to manage by another team. So this was almost the perfect scenario for us to consider a machine learning application, given that there was already a heuristics or rules-based system in place that a team was managing. So this was a great fit for us to look at since we wanted to be able to show the lift of what our model could provide over the rules-based system. If we look at a second example, this is one that was similar to what we were looking at as well. But let's say a team wants to use machine learning to provide recommendations on an infrequently visited part of the site. Now, obviously, this is already bad right off the start since it's an infrequently visited part of the site, and we're investing a lot of time to develop for this. So the first part to evaluate in this landscape is that we have no way to capture user signals or recommendations since a lot of the time people don't even go to this part of the website. So it's hard for us to know how effective our models are. The existing website cannot handle dynamic inputs, and there's very low business impacts. It's on a part of the website that is not frequently visited. So here, very obviously, this is a bad fit, probably isn't even something that's possible for us to implement. So no point in investing any time building an ML product for the space. The third example is an extension of the second, but what we are looking at here is that a team wants to use machine learning again to provide recommendations, but this time on a frequently visited part of the site. They've also, since the last example, built up a feedback mechanism where the user can give thumbs up or thumbs down, and they also consider clicks as well as a feedback system to whether or not the recommendations are good. So here, this is the landscape that we can see here is that the feedback mechanisms are great in terms of capturing the user signals on how effective the recommendations are. The team has made an update and we can now handle dynamic inputs. Another green light that this is great. And there is high business impact since we, let's say, get 10 million visitors on this part of the website per month, which can save the business a lot of cost. The last part that I wanted to add in as a twist to all of this is that we have uncertain stakeholders. And this happens pretty frequently where sometimes our stakeholders aren't sure of what machine learning is able to accomplish or what benefit it can really bring. And so if we have uncertain stakeholders, this makes this an uncertain problem. And one way or workaround from that is convincing stakeholders or convincing the groups that you're working with to allow you to conduct a pilot or to work with them to help address some of the problems that they're looking at. And we do run into this pretty frequently across multiple of my experiences at my previous company as well. So it's really important to consider this as an important part of the product development lifecycle. So now let's say that we've actually found a great problem. What are we supposed to do now? During this section here, what I wanted to touch on is how technical you need to get as a product manager and what to also consider when you are designing the experience of your ML product. So jumping to that topic first, as you're designing the user experience for your ML product, there's a couple of key things to consider. There probably is even more than this, but these are some of the most important things, in my opinion, to take a look at. So the first piece is taking a look at your overall, what use cases and user stories are you looking to address? A lot of the times, one thing that I find is often forgotten is what are the edge use cases we need to consider. This can often be the 20% of 20% of use cases that are actually considered, but can drive 80% of the problems that you end up coming into. A great example of this is when Twitter had built up a chatbot and ended up learning a lot of really, really bad behaviors from users. So this was an edge case that definitely should have been considered. But these are things that are really important to write down and almost do failure planning around to make sure that we have backup plans or we build up a rules-based approach to deal with those specific use cases. The second piece to look at is the UI design. This isn't applicable for all ML problems. Sometimes you have an ML product that is just operating in the background. But one important piece to consider around the UI design is what do we need to change in our UI so that we're setting the right expectations for our end users and its ML capabilities. I think Netflix oftentimes and Amazon does a great job at showing you where your recommendations come from. So they'll often show you because you looked at a certain product or because you watched a certain show, this is why they're recommending you something. And so it communicates to the user that it's a machine learning driven component or it's a recommender system driven component. And the second piece is that it also helps you to understand a little bit more about how the system thinks, which is really important in terms of building trust and setting the right expectation for our end users. The third piece to look at is the cost of error. So I think I mentioned this before, but what is the cost of actioning and what's the cost of making a mistake when it comes to your ML product? So a great example I like to talk about here is if we look at fraud prediction models. Let's say the cost of error is that if we find someone that we think has a fraudulent account and we end up shutting down and deleting their account, that is a very high cost of error because we've severely interrupted the user experience. And if we get a false positive for someone that we think is fraudulent, but they actually aren't, we've ended up losing a customer. So a lot of the times here, when it comes down to this level of a cost of error, it doesn't mean that we shouldn't build an ML product for it, but what we should consider is changing the precision versus recall and focusing a lot more on precision. I won't go into explaining too much on precision versus recall, but there's a lot of great resources on Google that you could probably take a look at to get a better understanding of what the two are. But generally, if the cost of error is higher, we tend to focus much more on precision. The fourth and last piece to look at is metrics. And so I usually work with a data scientist or machine learning engineer to define these, but they provide recommendations on what metrics we should be looking to prioritize and how we should be evaluating the effectiveness of our model versus the base solution that we have. One thing that I do work with our stakeholders on is figuring out how much error the stakeholders are okay with. And so translating what these metrics are saying to their stakeholders, as well as what level of tolerance or risk tolerance they are willing to have, is something that we usually converse with stakeholders on to make sure we're all aligned on the same page. Some frequent challenges that we often run into here are that with ML products in particular, there's a much longer development time without knowing what the outcome could look like. This oftentimes can scare stakeholders or execs when we're looking to invest in ML products. But at the end of the day, you are teaching a product to learn how to be the system. And so here this may impact stakeholder buy-in, but it's really important to figure out ways to de-risk and to be able to bring more value and to bring more outcome up further. And so some ways that you can look at de-risking the time to development is by performing offline analysis. And so this requires no integration. It only requires having the data and being able to perform and analyze the test data that we have. The second piece is doing a pilot or A/B testing for initial online analysis. And so these oftentimes allows us to work on a much smaller scale and not have completed the full integration that we would need. Both of these are great methods depending on the time and depending on where you are in the product development lifecycle. I have found before that performing offline analysis and showing that our model has potential for lift can really be very influential in terms of getting stakeholders to commit to doing a pilot and to commit to looking at investing in your ML product. The second challenge that I find we often come across is data availability. I think this one I kind of touched on earlier as well, but a lot of the times we are looking at predictive machine learning problems and it requires us to have labeled data. And a lot of the times we end up finding that we don't have the right amount of labeled data to train the model. Since you often need thousands, I think the number is usually 10,000 data points to be able to train up a machine learning model. This often requires a lot of manual tagging or for the team to hire data curators to actually go through the data and make sure that we have the right label data. In one scenario, we did get very lucky in that our advisors had labeling data basically as part of their process. So this made it a lot easier for us to get the right amount of data that we would need to train the problem that we were looking at. The last challenge is that there isn't always a great feedback loop. So what this means is sometimes there isn't always a clear signal from our end users on whether or not the prediction is correct or helpful. And so the ML model, of course, the improvement relies a lot on that and knowing whether or not we're actually providing lift in a live model. A lot of the times will vary on whether or not we can actually get feedback from the user. There are times too where the system doesn't actually end up capturing the feature or doesn't actually end up capturing the feedback. So this is also something to consider when we're looking at the overall landscape of what our systems are able to provide. Sometimes we need to build an extra data pipeline to bring the feedback back from the existing system into our data warehouse. So to sum everything up, today I think we covered two kind of topics here. One is what are the problems that are best solved by machine learning and what problems are not. So very generally speaking at a high level, the best problems to solve with machine learning are one that has high business impact as well as technical feasibility and are typically complex problems that are difficult to manage on a day-to-day basis. Also, use a scorecard when prioritizing multiple initiatives. This is a really great way to get all your thoughts down on paper and to be able to quantitatively assess what initiatives make the most sense. So to sum everything up today, There were two kind of main topics that we covered. One is what problems are best solved by machine learning and what are not. And typically what you want to consider here is machine learning problems that have high business impact and technical feasibility. If you have both of those, typically you have a win-win scenario. And also, if you have multiple initiatives that you are considering, try using a scorecard just to help get all your thoughts on paper when it comes to looking at all the various criteria. In terms of what you need to understand and how technical you need to get as a product manager of a machine learning product, it's important to consider and plan for edge cases that I mentioned. So a lot of the times, this is where you can get in trouble if you're not considering the cost of error with these edge cases. Work with your data scientists as well as machine learning engineers to define metrics and work with your stakeholders to figure out what the right risk tolerance is, and de-risk where possible in the product lifecycle. So try to bring up where the machine learning product can add value earlier in the lifecycle by doing offline analysis, as well as doing smaller pilots when you are launching. Cool. And that is everything for today. Thanks so much for joining me. You can find me and reach out on LinkedIn, but really appreciate everyone coming out to listen to this talk.